This video series provides details on how to put Synplify Premier software to work to make your FPGA-based design more reliable. Functional safety and highly reliable operation is required in FPGA deployments that are used in space, automotive, industrial, communications, and medical applications. The good news is that proactive SCU error detection and mitigation schemes can be built into your design to ensure correct operation and prevent system lockup. Synplify Premier automates the creation of this circuitry and allows you to control when and where to insert it in your design. Synplify Premier helps you to create functionality that is safe and highly reliable using your FPGA vendor devices of choice. The diagram on the left shows primitives on the FPGA die that need protection from the effects of radiation-induced errors. Combinatorial logic blocks, or CLBs, include registers, lookup tables, and DSP elements. The die also has dedicated memory primitives known as block RAMs, or BRAMs. It can include digital clock generators, or DCMs, and I/O buffers, IOBs. For each of these primitives, there is a unique SCU mitigation technique listed here and covered in the earlier videos in this series. The FPGA design will comprise macros such as finite state machines and IP. Special SCU mitigation methodologies can be applied here to protect each of these macros. Check out the earlier videos in the series for more details on how to do this. Here is a summary of techniques to use to protect FPGA primitives on the FPGA die from radiation-induced errors. In terms of specific techniques, redundancy and error correction using a technique called TMR is very popular and is used to protect logic cells, memories, registers, clock routing, and complex IP blocks. We can instruct the Synplify Premier software to select and use special error-correcting RAMs, ECC RAMs, in your design, if these primitives are available for your particular FPGA device. Special error flags can also be synthesized and tapped by Synplify Premier to enable you to monitor the overall design operation and to trigger actions such as memory scrubbing or other on-chip or software-based mitigation. Higher level macros in the design, for example, finite state machines, will also need protection to avoid lockup and incorrect behavior. And this can be done using, for example, Hamming 3 encoding to detect and correct errors in the FSM state register, and by the creation of error mitigation strategies implemented via safe FSM and safe case FSM techniques, all covered in the FSM video. The choice of which primitive is in the most need of protection will depend upon the FPGA device type, SRAM, or flash antifuse. All devices benefit from one or more of these techniques. Please refer to the introductory video, How and Where to Design in Functional Safety. This will give you more details. The good news is that all of these techniques are automated by and available in the Synplify Premier software. I hope that you found this series of videos useful. For more information or to discuss and evaluate Synopsys functional safety solutions, please feel free to go to synopsys.com/FPGA safety. Thanks for listening.